Okay, welcome to a McKenna Math tutorial right here. I'm gonna see what I can do. I don't know, I'm trying a whole bunch of new tech right here. So I'll see how I can work it and get things going. This first tutorial is gonna be on trig, and I'm gonna go through a whole bunch here and I'll cut it up. Even before we start trig, we gotta know how to label the sides of a triangle. So this first thing here is just all labeling. When we're given a trig question, to start off, we're going to have right triangles. Right triangle is one that has 90 degrees. That little square in the corner indicating that it's a right triangle. So on each of these triangles that are on the screen right now, we should be able to label the hypotenuse. Before we even worry about the opposite and the adjacent, the hypotenuse is always across from that 90 degrees. So if we look in the first one here, it's got right here our hypotenuse. And here's the 90 degrees. The hypotenuse is across from that 90 degrees. So if we go to the next one here, the hypotenuse is across from that 90 degrees. Now, some people also have been told that the hypotenuse is the longest side, which is also true. Here's this one. Across from it there is the hypotenuse. Works for all of them. As we get good, here's the 90 degrees. Across from it there, here's my hypotenuse. So once you get good at this, you can just look at it and know exactly where the hypotenuse is. Okay, it's key though. If you label the sides wrong, even if you sub into sine, cos, and tan correctly, you could get it right by accident, but you're messing up already. Okay, so the next thing is we're always given an angle that we're either trying to find or that the degrees are known. So in these triangles, A is here, and I always put a big mark like that on it. This is my angle, because you're gonna label the opposite and the adjacent according in reference to that angle. Now, the same way that we said the hypotenuse is across from the 90 degrees, the opposite is across from the angle that we're looking at. So that's why this one is our opposite, and then I think of the adjacent as the leftover. So if I come over to this first one here, here's my angle. I put a nice big mark on it. The opposite is the side that it's not touching. So it's touching this side, it's touching this side. That means down here has got to be my opposite. Okay? I can go and do this for all of them. Here it's touching this side and this side. That means this side down here has got to be my opposite. If I can bring the mouse over here, there's my angle. That means over here has got to be my opposite. There's my angle. Over here has got to be the opposite. My angle, opposite. Angle, opposite. Okay? And then we're essentially done. We're supposed to label the adjacent because that we use that in some of these ratios as well. Opposite and hypotenuse are already labeled, so the leftover has got to be that adjacent. So there's only one left. Adjacent. Only one left. Adjacent. Only one left here. Adjacent. 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 This one's already got a stick. Adjacent. There we go. Okay? So that's a key part, is just labeling the sides, being able to do that. Because as we continue here, once we've got these sides, now again, this one here is our angle right here. That's the important angle, right? Across from the 90 is our hypotenuse. Across from the angle is our opposite. And down here is our adjacent. These are our three trig ratios. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan, and I didn't mention the angle, but tan of the angle is the opposite over the adjacent. I think in our class somewhere, at least in my class last year, I'll have to see, we had this to kind of remind us. That was posted somewhere, and it's exactly this. So sine of an angle is the opposite over the adjacent. That's our first one. Cos of the angle is the adjacent over the hypotenuse, and tan of an angle is the opposite over the adjacent. Okay? Kind of like our formulas. They're ratios. They are formulas that we're subbing into, but they're ratios of sides given an angle. Okay? On our worksheet, we're going to use these. So, the way that we're going to set this up, for example, number 1 says sine A. So here's an angle A. Right? I put my mark on it. Sine is opposite over hypotenuse. If we forget, maybe I can write it up at the top here. Probably good to get good at that, so you get on a test or whatever, you write that up at the top. So sine is opposite, which is 5, over hypotenuse, which is 13. So wherever there is a 1 down here, we're going to want to put an R. And I think there's just one. So we come back up here, cos of A. So that same angle, now cos is adjacent over hypotenuse. Adjacent would be 12. We can label these if we want to. Hypotenuse across from the angle is opposite. Down here is adjacent. That makes it super easy because now it says cos of the angle adjacent over hypotenuse. 12 over 13. What one is it? 12 over 13 is I. So wherever there's a 2 down here, I'm going to put my I. There we go. And then we would just keep going like this. Now, there's one part I'm going to jump over to 13 where it could get a little bit tricky. It's got a trick in it. So these are all about angle A. Okay, so I'm going to mark my angle A. Now, if we did the first one, I'm going to label it. Across from the 90 degrees is my hypotenuse. Across from my angle is my opposite. And that means my leftover is my adjacent. Okay? Now, if I did sine, that would be opposite over hypotenuse. 12 over 15, right? But there's no answers like that, 12 over 15. We got 5 over 3, 3 over 5, 4 over 3, 4 over 5. So something's happening here. This is the trick. If you've seen it already, awesome. Or if you've figured it out already, awesome. What we got to do is we got to reduce that fraction. If you're good at reducing, awesome. We can see that we can divide out a 3 from 12 and a 3 from 15. So it should be E 4 over 5. But if you're not good at reducing, I'm going to show you a little trick here. On your calculators, if you've got a calculator like this, right here, I don't know if you can see it, but it's an A, B over C button. Mine looks like this. Where's my pen? A, B over C button. If I type in 12, where am I? 12, push my A, B over C. It's a fraction button. 12 over 15. And I hit equals. I don't know if you'll see it on there. 12 over 15 equals 4 over 5. It's reducing that fraction for me. I don't even have to think. So if you got a scientific calculator, if you haven't got one, I think this one's $13 at Walmart. Right there, A, B over C reduces fractions for you. It's got the sine, cos, tan buttons that we're gonna need. So for 13, wherever there's a 13 down at the bottom, found my 13. That one is gonna be an E. We had a little trick there where we had to reduce that fraction to figure it out. Okay? There's more reducing stuff like that throughout a couple of these. So one other thing to notice is, does it show up? I'm going to leave that trick, and if people have questions they can ask me. Maybe they'll be tricked, maybe they won't. So yeah, we'll give this one a try.